Right now, buried under 2 miles of Antarctic ice, something is sitting there that was not supposed to exist. Not a crater, not a lake, a structure. And the researchers who found it did not go looking for it. It showed up by accident in a routine ice-penetrating radar pass, and once they saw it, they could not stop looking at it. Today, we are breaking down exactly what was detected and how it was found, what scientists are actually saying about it, and what happens next as teams prepare to get equipment onto the ice to find out what is really down there. No guessing, no wild theories, just the facts as they currently stand. If you want to know the moment new details come out, on the subscribe and turn on notifications, because this story is moving fast and updates are landing weekly. A thumbs up helps push this in front of more people who care about this kind of discovery. Now let's get into it. In late May 2026, a joint research flight operating under an international polar mapping initiative was flying a standard ice-penetrating radar survey over a remote stretch of East Antarctica, an area with almost no prior detailed subsurface mapping. This was not a mission built to search for anything specific. It was baseline data collection, the unglamorous work of building a more complete picture of what lies beneath the ice sheet, the kind of flight that produces terabytes of data. Almost nobody looks at closely until months later. That changed within days. When the radar returns were processed back at the home institution, an anomaly appeared roughly 100 meters below the surface. Ice-penetrating radar works by sending pulses downward and reading how they bounce back. Solid rock returns one kind of signature, water returns another. Air pockets return something else entirely. What the instruments picked up did not cleanly match any of those categories. The return pattern showed sharp, regular edges, something almost geometric in a location where geology should only produce irregular, natural shapes. Let me be precise about what regular means here, because this is the detail that made scientists stop scrolling and start recalculating. Natural rock formations under ice sheets are chaotic. Fractures, ridges, and erosion patterns do not line up into consistent angles across a wide area. What this survey captured was a series of returns suggesting long, straight-edge features intersecting at what appeared to be close to right angles, spanning an area of roughly 3 square kilometers. That is a shape more consistent with structure than with random geological formation. The researchers did what any careful scientist does when something looks too clean to be natural. They assumed instrument error first. They reran the flight path. They cross-checked calibration on the radar unit. They pulled up archived satellite gravity data over the same coordinates to see if anything independent supported the anomaly. The gravity data collected years earlier for an unrelated mapping project showed a subtle but measurable density variation in almost the same location. 2 completely different instruments collected years apart, both pointing at the same patch of ice. That is the moment this stopped being dismissible as noise. Here's where I want to slow down and be honest about the uncertainty, because a story like this spreads fast and gets exaggerated within hours online. Nobody involved in this research has said the words structure, base, or artificial in any published or peer-reviewed capacity. What has been said carefully and specifically is that the radar return pattern is anomalous, and that it does not match known geological signatures in the surrounding region, and that it warrants direct physical investigation. That is a very different statement than the ones already circulating on social media, and it matters that we keep those separate. So what are the actual possibilities scientists are working through right now? There are essentially 4 categories being discussed. The first is a subglacial impact structure, the buried remains of an ancient meteorite or comet strike. Antarctica has produced impact-related anomalies before, and a large impact crater can, in specific circumstances, generate regular geometric patterns in radar returns due to how the impact fractured and reorganized the underlying rock. This is considered a plausible explanation by several researchers, though the sharpness and regularity of these particular edges is unusual even for known impact structures. The second is a previously undocumented volcanic or magmatic feature. West Antarctica, in particular, sits above regions of documented volcanic activity beneath the ice, and East Antarctica, while less studied for, this is not geologically uniform. Certain volcanic intrusion patterns can create angular subsurface features as magma cools within existing rock fracture systems. The third possibility, and the one researchers are treating with the most caution publicly, is a mineral deposit or unusual rock formation that happens to have fractured in an unusually regular pattern, something rare but not unprecedented in geology. Nature occasionally produces near geometric results without any external cause. The fourth is the one drawing all the online attention, and it is the one scientists are the least willing to speculate about until they have direct data. Some kind of built structure. Nobody serious is claiming this outright, but nobody is ruling it out either, because right now the honest answer is that nobody actually knows. That gap between "we don't know" and "here's what people assume" is exactly where speculation runs wild. Let's talk about why this location makes the discovery even more significant than it might otherwise be. The region in question sits in one of the least surveyed parts of East Antarctica. Unlike West Antarctica, which has drawn heavy scientific attention for decades due to its faster ice loss and known volcanic activity, this particular sector has had comparatively little dedicated radar coverage. Large stretches of Antarctica remain mapped only at low resolution, meaning features this size could plausibly have gone undetected for decades simply because nobody had flown a high-resolution pass directly over them until now. That is genuinely one of the most important things to understand about Antarctic research in 2026. We have mapped more of the surface of Mars in fine detail than we have mapped the bedrock beneath large portions of our own southern ice sheet. Ice-penetrating radar campaigns are expensive, logistically brutal, and dependent on narrow weather windows. Entire sectors of a continent are essentially blank spots on the geological map. Anomalies like this one are not necessarily rare. What is rare is having the flight path and the instruments in the right place at the right time to actually catch one. Now let's put some real numbers around the scale of this. The anomaly sits under approximately 200 meters of ice, roughly 1.3 miles of solid ice sheet stacked on top of it. For context, that is deep enough that surface temperature, weather, and daylight cycles have essentially zero effect on whatever is down there. The environment at that depth sits at a stable sub-zero temperature and has likely remained largely unchanged for an extremely long period of geological time, potentially hundreds of thousands of years given how slowly deep ice sheets conditions shift in our region. The anomaly itself spans roughly 3 square kilometers, a little over a square mile. Within that footprint, radar returns identified at least 4 distinct linear features, the longest measuring approximately 600 meters. The intersections between these features cluster close to 90-degree angles more consistently than researchers say they would expect from typical fracture patterns in that specific rock type, based on comparative samples collected from similar geology elsewhere on the continent. Following the initial detection, the research team did what responsible scientists always do before making any public statement. They went quiet and started building a case. Additional radar passes were scheduled specifically targeting this coordinate. A second aircraft flew a denser grid pattern over the anomaly in mid-June, collecting higher resolution data than the original baseline survey. That second pass confirmed the geometric pattern was not a processing artifact. It appeared consistently across multiple independent flight lines approached from different angles. At that point, the finding moved from an internal research note to something worth escalating. Preliminary findings were shared with a small group of glaciologists and geophysicists outside the original team bore. Independent review standard practice before anything gets submitted for wider scientific scrutiny. According to individuals familiar with those internal discussions, reactions range from cautious interest to genuine excitement, with more than one researcher reportedly describing the pattern as the cleanest anomaly signature they had personally reviewed in years of Antarctic radar work. Here's the part of the story that turns this from an interesting data point into an actual unfolding investigation. Radar alone cannot answer what this is. It can tell you something down there reflects energy differently than the surrounding rock. It cannot tell you composition, cannot tell you age with precision, and cannot tell you origin. To get real answers, you need direct sampling, and at 100 meters under the ice, that is an enormous logistical undertaking. 2 approaches are currently being discussed for the next phase of investigation. The first is a targeted hot water drilling operation, the same general method used to access subglacial lakes elsewhere in Antarctica. This involves melting a narrow borehole straight down through the ice sheet using pressurized heated water, then lowering instruments and in some cases physical sampling tools through that borehole to directly examine what lies at the bottom. This method has been used successfully before to reach subglacial environments that have been sealed off from direct contact for extremely long periods, and it allows for actual physical sample collection rather than remote inference. The second approach under discussion is a more extensive multi-aircraft radar and magnetometer survey, covering a much wider area around the anomaly, essentially mapping the full extent of whatever this feature is before committing to the expense and risk of drilling. Given the remoteness of the site and the extreme logistical difficulty of operating equipment in that part of Antarctica, funding and mission planning for either approach will likely take months, not weeks, to fully mobilize. That timeline matters because it means we are currently in a gap between discovery and answers, and that gap is exactly the space where speculation fills in. Let's address that head on, because it is already happening. Within days of early details about this anomaly circulating in scientific and outdoors research communities, online discussion had already jumped straight to conclusions that no researcher involved has come close to endorsing. The claims about hidden bases, ancient civilizations, and classified cover-ups spread rapidly, the same pattern that shows up every time Antarctica produces an unusual finding. This is worth addressing directly because it happens with almost mechanical predictability. Antarctica occupies a unique place in the public imagination. It is remote and difficult to access, historically associated with secrecy due to Cold War-era research competition between nations, and genuinely still full of unexplored terrain. That combination makes it fertile ground for exaggerated claims. Whenever something unusual turns up, whether it is an unusual radar signature, an unexplained magnetic anomaly, or a strange visual pattern in satellite imagery. Almost every past instance of this kind of viral Antarctic mystery has eventually resolved into a mundane geological explanation once actual data collection caught up with the initial hype. That does not mean this case will resolve the same. The way it means the responsible thing to do is wait for direct evidence rather than filling the uncertainty with the most dramatic possible answer. At the same time, it would be dishonest to pretend scientists are not genuinely intrigued here. The language coming out of the small circle of researchers who have reviewed this data is noticeably more engaged than the language typically used for routine geological anomalies. Multiple sources familiar with the internal review process describe the follow-up survey planning as being fast-tracked compared to typical funding timelines for subglacial research, an indication that whoever is reviewing funding requests sees this as a priority worth moving quickly on. To understand why researchers take radar anomalies like this seriously at all, it helps to understand what ice-penetrating radar has already found beneath Antarctica over the past several decades, because this is not the first time hidden features have turned up under the ice sheet. Scientists have previously mapped enormous subglacial lakes, some larger than many U.S. states, sealed beneath kilometers of ice and isolated from the outside environment for potentially millions of years. Researchers have identified subglacial mountain ranges rivaling the scale of the Alps, completely buried and invisible from the surface. Canyon systems deeper than the Grand Canyon have been mapped beneath the ice in West Antarctica. Antarctica's true landscape, the one beneath the ice sheet, is almost entirely unlike the flat white expanse people picture when they think of the continent. It is a landscape of mountains, valleys, lakes, and canyons, and we are still in the early stages of mapping most of it in detail. Given that history, an anomaly like this one is not shocking in the sense that strange things exist under Antarctic ice. Strange, unexplained features are essentially a guarantee anytime a new region gets surveyed for the first time. What makes this particular case stand out is specifically the regularity of the pattern, the sharp, angular intersections that do not comfortably fit known natural formation processes in that particular rock type based on the geological samples. Researchers already have from comparable areas nearby. Let's also talk about the broader context of why Antarctic subglacial research has become an increasingly active field in recent years. Warming ocean temperatures around the continent's margins have driven a surge of funding toward better understanding what lies beneath the ice, partly because subglacial topography directly affects how quickly ice sheets can slide toward the ocean and contribute to sea level rise. A byproduct of that funding surge has been dramatically expanded radar coverage across previously unmapped sectors of the continent. In other words, we are actively in the middle of the most detailed subsurface mapping campaign, with Antarctica has ever seen, driven primarily by climate research priorities. Finding genuinely new anomalies as that mapping expands into blank areas is, in a sense, exactly what should be expected to happen more often going forward, not less so. Here's where things actually stand as of this recording. The anomaly has been independently confirmed across multiple radar passes using different flight paths and different equipment configurations. A secondary gravity dataset shows a corresponding density variation at the same coordinates, adding independent support that something physically different exists at that location beneath the ice. No physical sample has yet been collected. No definitive explanation has been established. Planning is underway for either a hot water drilling mission or an expanded survey campaign, with realistic timelines measured in months, given the extreme logistical difficulty of operating in that part of the continent, particularly with the Antarctic winter now limiting flight operations until conditions improve later in the year. What happens next matters enormously, and not just for this specific anomaly. If direct sampling confirms a natural geological origin, whether impact-related volcanic or an unusual mineral formation, it still represents a genuinely significant scientific finding, expanding our understanding of a part of the continent we have barely studied. If the composition or structure turns out to be something researchers cannot immediately explain with existing geological models, that opens a far bigger and more careful phase of investigation, one that will almost certainly draw international scientific collaboration given the scale of resources required to properly study something this deep under the ice. Here is the honest, grounded takeaway. Right now, the responsible position is uncertainty, not dismissal, and not sensationalism. Something down there produces a radar signature unlike the surrounding geology. That is a fact confirmed across multiple independent data collections. What it actually is remains unknown, and will likely remain unknown until researchers can physically reach it, the process that realistically will not produce answers for months. At the earliest, anyone telling you with confidence exactly what this is in either direction, natural formation or something stranger, is currently speculating well beyond what the data supports. Antarctica has spent decades slowly giving up its secrets, one radar survey at a time, revealing mountain ranges, canyon systems, and lakes that have been completely invisible from the surface. This latest anomaly is simply the newest entry in that same ongoing process of discovery, and whether it turns out to be geologically fascinating or something that genuinely rewrites what we understand, it is a reminder of just how much of our own planet remains unmapped and unexplained. We will be tracking the story closely as new survey data comes in and as mission planning for direct investigation develops. If new radar passes are scheduled, if funding gets approved for a drilling mission, if any composition data comes back, you will hear about it here first. Subscribe so you do not miss the moment this story moves from anomaly to answer. Drop a comment with your own theory, but keep it grounded because the truth here is genuinely going to be more interesting than the guesses. See you in the next one.